Good morning, everybody. We're really grateful to be a part of this Thrive cohort, and really excited to be here this morning to have an opportunity to tell you all about Boost Biomes. My name is Rob McBride, and together with my co-founders Jamie Batcher, who's in the audience, and Adam Arkin, we started Boost Biomes about a year and a half ago, leveraging some microbial discovery technology that we have a license to from Lawrence Berkeley Labs that allows us to discover microbial products for agriculture. And we're really excited about this technology because we think this is a huge challenge, driven primarily by the fact that we've got a fixed planet, right? A fixed planet with a population that's growing, whose appetite is growing. And the simple math of that equation means that by 2050, we on average have to double productivity. And so in the face of needing to improve yields, we're facing huge pest pressures. You know, on a yearly basis, we lose approximately enough food to feed 600 million people, just from the impact of fungal pests. The toolbox that we have to manage those pests is decreasing in its efficacy as microbes and other pests become more resistant to those chemicals. The amount of new solutions coming into the market in the chemical space is decreasing over time, in part driven by the fact that the amount of time to develop those solutions and the amount of money that it costs to develop those solutions is increasing. So right now, on average, it takes about 10 to 12 years and $300 million to develop a new chemical solution for agriculture. So we think that microbes offer a great alternative. Not only can you develop them faster and for less money, but they also offer new modes of action and safe and sustainable options, right? And so we don't view microbes, at least in their current iteration, necessarily as complete standalone replacements for all chemicals. We think about microbes as an integral part of a integrated pest management strategy to manage yield and extend shelf life of existing chemistries and ensure that we have a future that's sustainable and exciting. The platform that we use to discover microbes, as I mentioned, we're licensing it from Lawrence Berkeley Lab. It was developed by our co-founder, Adam Arkin. We're calling it Tether. And it allows us to identify robust commercial microbial solutions faster, for less money, and that are more effective than traditional approaches. And the science that underlies this essentially is predicated on the fact that microbial diversity in the environment is structured primarily by microbial interactions. And if you can understand those interactions, then you have a rational basis for identifying new microbes that you can turn into products. How this works in reality, this is actual data from our platform. So this is the interaction map. The squares around the map, or triangles around the map, rectangles around the map represent microbes. The lines between the rectangles represent interactions between those microbes. Red lines are negative interactions, blue lines are positive interactions. This red box over here is Fusarium. That's a pest, that's a bad microbe. Those blue boxes represent unique strains of Bacillus, which negatively impact Fusarium and importantly, positively impact each other. So when we've identified those as potential microbial candidates, we pull them out, we isolate them, and in the lab we say, hey, do these microbes do what we think they should do? And it turns out that they impact Fusarium negatively, and they impact other fungi negatively. The key question, though, is you can discover microbes in the lab. Does this discovery platform translate to the field? And so we have some early field data showing the impact of that consortia that I just showed you on botrytis. It turns out that when you don't treat blueberries for botrytis, the untreated control, the gray bar, you get a lot of botrytis. The red bar is the industry standard. That's a rotation of different chemicals that manages botrytis really well. Lifeguard and Stargus are two existing biological sort of solutions on the market now that you can buy. And you can see that the blue bar, our first product that we're trialing in the real world shows statistically identical efficacy to other products that are on the market. So we're really excited by this. We think this is great initial progress as it shows that our platform identifies microbes that work in the lab and that those microbes also work well in the field. Our approach is differentiated and novel to discovering these microbes. There's a lot of companies out there trying to take advantage of the microbial diversity to develop new products. And if you're one of those companies, you essentially have three approaches available to you, right? One is to screen large libraries of microbes. The other is to use plants to select different microbes. and the other is a sequencing-based approach which correlates microbial occurrence with different plant phenotypes. So in contrast to these approaches, the Boost Biomes approach, which is to develop causal microbial networks as a discovery platform, allows us to identify microbial solutions in less time for less money than traditional approaches, and it's simple for us to identify consortia. And we think that's really important because consortia reduces the probability that you'll get resistance to the product, and it also makes it more stable across environmental gradients. This is our strategic path forward. Starting at the top here, this is our blue line, our most important line, our funding line. Currently, we're in the middle of our seed round, and we have 2 deliverables for that seed round, 2 important milestones. One is to continue to validate that our products work in the real world, so we're doing small-scale commercial trials. And the other is to do strategic discovery with hopefully some strategic partners. We are interested in expanding some of those deliverables, so if anyone interested in talking to us about that, please touch base with Jamie or I. We're hoping to use the strength of the data that we generate in our seed round to raise an A round in early 2019. The primary focus of that will be to get fungicide labels in early sales, as well as to demonstrate the breadth of the platform, right? So this can discover microbial candidates in a number of different areas, and we're hoping to show that we can do discovery with row crop pests, different inputs, and plant stress. This is some of our early financial projections. A few things to take home from this. We're starting on a few crops, and we're expanding the acreage of those crops over time, as well as adding new crops to the mix. As well as the other thing to take home is that our COGS are meaningfully impacted by scale. So once we get to a certain scale, our COGS improve dramatically. We have a really experienced team. Jamie and myself together have 18 years of industry experience, and Adam's been thinking about how to figure out microbial interactions for the last 20 years or so. Karen and Veronica are our great scientists, and we're really lucky to have Chris and Jasper as our advisors. So they're both National Academy scientists, and both have been very successful in startups in the agricultural space. So just to wrap things up, we have a breakthrough innovation, we have an experienced team, we have an ambitious vision. We're really excited to be here, and we're hoping to connect with customers interested in trialing products, prospective Series A investors, and strategic partners in the agricultural space. And lastly, there's no way we would be here today without the significant and meaningful help of a lot of different people, and I've listed some of them down here below. And with that, I'm going to wrap up and hopefully take some questions.